right, 6.5, graphs of polar equations. So some of these notes, I'm just going to tell you where to reference, like, the stuff in the box or whatever, like, on the page, because it's, like, got the domains for all the different types of polar graphs and all of that, which is important, I'm sure, but at the same time, I also think that there's other things that are more important, and you can just kind of reference that when you get there. You're going to mess up his ears, you know.
Here we go, though. I'm switching.
Anybody listening to this in the future is going to be like, what?
He's gonna be deaf.
This one's ears looks like he got, like, he lit a fire or something. Like, burned it.
All right, the symmetry test for polar graphs. The graph of a polar equation has the indicated symmetry if either replacement produces an equivalent polar equation so I'm going to have 3 columns here. So to test for symmetry, what we're replacing, which is all going to be the same, and then by what.
Can you just send me a picture of these notes?
Yeah, that's fine.
Thank you.
Sure, it's hard to write.
A little bit.
All right, the first one is about the x-axis. I can also print them if that would be easier. When we're done, I can send them to the printer. So
Either
you
one's fine.
okay. So replace r theta by r negative theta or negative r and pi minus theta. 2, about the y-axis, r theta. So basically, the first one was it flipped over the x-axis, this one flipped over the y-axis, and this would be if we swap it with negative r negative theta or r pi minus theta. And then the last option is about the origin. R theta, so negative r theta or r and theta plus pi would be what we're subbing it out with. So it appears that there's going to be 3 different types of curves, at least that our book goes through. When we look at the prep book stuff, there might be a few others that we need, but our book only does 3, so I'm going to start with those, and then when we look through that stuff, we'll check. So the first one are rose curves. The graphs of polar equations r equals a cosine of n theta and r equals a sine of n theta, where n is an integer greater than 1, So as long as the number in front of theta is greater than 1, we have a rose curve. If n is odd, there are n petals. If n is even, there are 2 n petals. So for an even number n, we have to multiply it by 2 to see how many petals. For odd, we have as many petals as the number that's in front. So just for a visual of what this could look like, obviously this is not going to be perfect, but just roll with it. Kind of looks like a flower, right? A little bit. When it's drawn, you know, perfectly out of the book or your calculator, it's going to look a little nicer, but just for a visual. So this one has 8 petals on it, so that would have meant that n was 4 in this particular situation. So, just for reference. Okay, this next type, I'm probably going to say it wrong, but according to the phonetic pronunciation, it's limason. Okay, I think. I don't know. I'm not really good at that whole phonetic thing, but we're going to roll with it. But it's spelled like this, Limac with a little like apostrophe under it. I don't really know. Anyways, On, curves. And anyone want to take a wild guess of what this word means?
Lemon.
In
Something.
Old French.
Yeah, I knew that was a French C.
Yeah,
Something with
it's like
lines with curves.
that's not with. That is
I'm going to
not
give you a
something like
hint. It's
S.
not something mathematical.
Okay, so maybe it's not limitation.
I really think it's like lime or lima beans. Lemons with curves.
Liminal.
It means snail.
What?
Oh.
Well,
Just in case you wanted to know, this means snail.
I would not have gotten that. That is in fact escargot. Oh yeah.
Is this like a snail?
It's the Old French for snail. That's what it says.
So maybe there's a difference between like old French
Is that a
and
snail?
newer French. We're gonna find out here.
I don't know.
This is graphs of polar equations of the form r equals a plus or minus b sine theta and r equals a plus or minus b cosine theta, where a is greater than 0 and b is greater than 0.
I think you missed the E at the end of where.
I was like, something doesn't look right. There are 4 different shapes of these. They're on page 498 at the top. But the options are that fancy L word, with an inner loop, cardioid, a dimpled fancy L word, or a convex fancy L word. Anyways, but there's pictures of what all those look like. I think they're also in that packet, so also I'm not really going to draw them, but if you're so inclined to want to draw them, you're welcome to do that. And there's restrictions on like A and B and A divided by B and all that for each one of those, so anyways. The stuff that goes with the rose curves up here about the graphs of them is on page 497, that deals with like the domain and all of that. So I'm just going to put graph information up there for the rose curves, is on page 497. And it talks about how you know like if n is odd and it gives you other information, then how you know it's symmetric about each like thing and whatever with that. And then this one for this type, don't fall off, the graph information is on page 498. And then the other ones, well, apparently there's some spiral of Archimedes, but there's really no notes about it. But that's the one that kind of like literally just makes the spiral that just goes around and around and around like that, you know. Where it'll stop, nobody knows. And then the last one that our book deals with is a lemniscate. So another fancy L word, but a little easier to say, curve. And I'm not 100% sure I'm saying that right, so like don't go home and be like, we learned about this, and your parents are like, that's not how you say it, because like I might be saying it wrong, but I'm just saying it as it looks.
I don't think they know how to say it.
But they are graphs of polar equations of the form r squared equals a squared sine of 2 theta and r squared equals a squared cosine of 2 theta. And again, there's not a whole lot of information about this, but anybody know what the shape of this graph would be?
Is it the one where it's just like a little curve?
If you know, this is the fancy name for something.
Lemon. Again, I'm going.
A mathematical thing this time.
Oh, okay. Limits. Liminal.
Linear.
I don't like this game anymore. Is it like a common shape?
Where to... Well, I don't know if shape's the right
Square.
word. I mean, it is a shape, but it's not a shape. Like, you wouldn't think of it as a shape.
Parabola.
No. Where do limits often go?
Infinity.
Ah.
So this-
How do we graph that though? The calculator.
So this graph would be, like, on the axis like that. And there's no other information about those in the book either. So I think that the little prep packet thingy will have a few things. So that's all the notes from the book.